Okay, so for the Christmas concerns, we're going to start with question 1 right here. If Santa Claus was born 100 years ago today, how many days old would he be today? So now we're going to go to the next slide and work through that problem. So, Santa, if he is 100 years old, we need to consider how many days there are in a year. In a typical year, there are 365 days. So now I want you to grab your calculator and figure out how many days there would be in 100 years. You should have found that there are 36,500 days. But you can see over in the corner a little frog there reminding us that there are leap years. So every 4 years there are leap years. So now we need to consider how many leap years there are in 100 years. There's 100 years, and every 4 years is a leap year. So we need to divide this up into how many times that would happen. So 100 divided by 4 would give us how many extra days. And if you put that in your calculator, you should have found 25 extra days. So now Santa's age in days is 36,500, and the extra 25 days when we consider leap years. So 36,525 days old. That's a lot of days. All right. We go back to our worksheet. Our next question, number 2. Santa plans to leave San Francisco at 6 p.m. on Christmas Eve. It will take him 4 hours to fly to Miami, Florida. What time and what day will he arrive in Miami? So I'm going to go to the next slide and we'll work through it. All right, so here I have a map to help you visualize this. If Santa is in San Francisco, that's in California, over here on the west coast, and he's flying to Miami over here on the east coast, what day and what time will he arrive there? Well, it said he left San Francisco at 6 p.m. and it took him 4 hours to get to Miami. So 6 p.m. plus 4 hours would get him to Miami at 10 p.m., but that would be, sorry, that's a silly looking M, that would be Pacific time. What time is it in Miami, which is Eastern time? As you can see, Pacific time at 3 p.m. would be 6 p.m. Eastern time, which would be a difference of 3 hours. Eastern time is 3 hours ahead. So 10 p.m. is Pacific time, but 3 hours ahead, 11 p.m., 12 p.m., 1 a.m., right? Elapsed time, 1 hour, 2 hours, 3 hours. That would get him there at 1 a.m., which would not be Christmas Eve anymore. It would now be Christmas Day. All right, let's take number 4. We're on number 3. Here we are. Your mother gives you a choice of how many pieces of candy you would like to have in your Christmas stocking. Look at the following choices. Convert them into decimal system and choose the one that represents the most candy. When they say convert to decimal system, that means make them look like numbers we're used to seeing. The first one, part A, that's in Roman numerals, so we're going to have to convert the Roman numerals. Part B is talking about 39 dozen pieces of candy, and part C is an exponent, 22 squared pieces of candy. So let's make them look like numbers we're used to seeing so we can compare which one gets you the most. So what I have for you on this slide is Roman numeral conversions to remind you of what they all stand for. So part A wanted you to convert the Roman numeral C, D, L, X, I, V. So what number does that Roman numeral stand for? So we need to come over to our chart and let's find CD. Well, let's see. CD is right here. And D stands for 500, but you have a 100 in front of it, which means it's taking that much away. So CD would be 400. And then we have LX, which is actually on here, right here. LX stands for 60, and an IV stands for 4. So when we put all of those together, that would be 464 pieces of candy. That's part A. Now you need to compare that to part B, 39 dozen. You need to know what dozen means. A dozen means 12. So if I have 39 dozen, what am I going to do with those two numbers? Hopefully you thought to multiply them. When you multiply 39 times 12, that will give you how many pieces of candy. So here's a good time to grab your calculator. You should have gotten 468 pieces of candy. And then our last option is 22 squared. That's straightforward. You just type that into your calculator and hit enter. And that should get you 484 pieces of candy. And then when you compare that to the previous two, that would get you the most candy, if that's what you're interested in having. All right, back to our page. We have our next question with the reindeer, number 4. Rudolph flies 3 times as fast as Cupid, but only 2/3 as fast as Blitzen. If Cupid flies 320 miles in 4 hours, at what speed per hour do each of the 3 reindeer fly? Cupid, Rudolph, and Blitzen. Those are the 3 we're looking for. So we're going to go over to the next page so we can work through this one together. And here we have the reindeer, and I realized after I put this on here that we're missing Rudolph, the most important one. So I'm going to change comment. You're going to be Rudolph instead. And to make this historically accurate, we're going to put his red nose on there. All right, now we're ready to start. Okay, they told us that Cupid traveled 320 miles in 4 hours. Well, given our distance formula, distance equals rate times time, we need to figure out the rate. So I'm going to solve this literal equation for R. So now I know the rate is the distance divided by the time. So Cupid's rate would be 320 miles divided by 4 hours. So go ahead and grab your calculator and see what his rate would be. You should have gotten 80 miles per hour. All right, so from there, we're going to talk about Rudolph. There he is. It said that Rudolph flies 3 times as fast as Cupid. Well, we just found out that Cupid goes 80 miles per hour. So Rudolph goes 3 times as fast as that, so we should take the 80 and do what with it? Hopefully you multiplied it by 3. So 80 times 3 would be how fast Rudolph could go. And if you put that in your calculator, you'd see that he goes 240 miles per hour. And then there was Blitzen. Blitzen, let's see, Rudolph flies 3 times as fast as Cupid, but only 2/3 as fast as Blitzen. So if we knew Blitzen, we would take 2/3 of that to find Rudolph, but we know the reverse of that, the opposite or the inverse. We know Rudolph, not Blitzen. So if I know that it would have been 2/3, if I do the opposite or the inverse, I could take 240, and instead of multiplying it by 2/3, I'd multiply it by the inverse, 3/2, 3/2, to find out Blitzen. So now, grab your calculator and type in 240 times 3/2. Be sure to use your parentheses. You should find that Blitzen goes 360 miles per hour. Those are some fast reindeer. I guess you have to be if you're going to make it around the world in one night. Okay, on to our last problem. Number 5. Mrs. Claus is concerned about her weight. Last year she weighed 2/3 what she weighs this year. This year she weighs 1.5 times what she weighed 2 years ago. If Mrs. Claus weighed 160 pounds last year, how much did she weigh 2 years ago, and how much does she weigh this year? So we need to find all 3 pieces of information. So let's go. All right. There's Mrs. Claus and Mr. Claus working out, trying to burn off that extra weight she's put on. Let's take a look and see. This is a lot of reading that we need to go back and reread so that we can make sure we have all of the components that we need. So she's concerned about her weight. Last year she weighed 2/3 what she weighs this year. This year she weighs 1.5 times what she weighed 2 years ago. If Mrs. Claus weighed 160 pounds last year, how much did she weigh 2 years ago, and how much does she weigh this year? Okay, so I've now read it twice. I now can see that she weighed 160 pounds last year. I'm just going to record that here. Last year, she was 160 pounds. Last year, that 160 pounds was 2/3 of what she weighed this year, and this year she weighs 1.5 times what she weighed 2 years ago. So if I could figure out 2 years ago, let's let X be weight 2 years ago. Okay, so that's her weight 2 years ago. Well, then that means that this year, her weight is 1.5 or 1.5 times that 2 years ago weight. So we've got that piece of information on there. Okay, so from there, we can try to find last year's weight, which they told us was 160 pounds. But what they also told us is that last year's weight is 2/3 of this year's weight. So if I said, okay, I've got this year's weight, and I multiply that by 2/3, what you're going to find, if you put 2/3 times 1.5 in your calculator, you're actually going to get 1x. They end up being the same thing. So that tells us that this was last year's weight, which we know is 160 because they told us that up here. And using what they said down here, we were able to confirm that last year's weight is 160. If we know that, then now we know that we could type x equals 160. We can plug that in for x up here. 1.5 times 160, because we know that's what x equals. That's 240 pounds. And let x equal the weight 2 years ago. Well, we found x was 160, so 2 years ago she still weighed 160 pounds. And then last year she weighed 160 pounds, and then all of a sudden this year she weighs 240 pounds, and that, my friends, is why she is on the treadmill. All right, good job. Let me know if you have any questions.